All right, welcome everybody. Today we're going to be talking about a little bit different topic from our normal sessions. We're going to be covering reality computing. You may have started to hear some of this, some talk of this concept recently. So, we wanted to kind of give you guys an idea of, kind of what this is all about. So, my name is Eric Ritchie. I'm here from the customer engagement team from Autodesk. Today, speaking to us will be Robert Shear. He's our senior director at Reality Solutions. As is usually the case with these webinars, we love hearing from you guys. So if you have questions during the presentation, feel free to use your GoToMeeting widget. Just type your question into the panel, the question panel at the side of the screen there, and we'll have some time at the end of the session to kind of do some follow up with you guys. Otherwise, for some more information, after this session about reality computing in general, you can head on over to realitycomputing.com, or you can shoot us an email at realitycomputing@autodesk.com. So with that, I'm going to turn things over to Robert Shear.
Excellent, excellent. Thank you, Eric, and welcome everyone. So my name is Robert Shear. I look after what we call the Reality Solutions Group. So if you use ReCap or Memento or any of those products, that's what we do. Eric's part of that team. I'm based in San Francisco and very happy to be with you today. As you can see from this slide, this is an AU slide. So I did a session at AU on this. What I plan to do here is a slightly abridged version of that, and hoping to give some time at the end for questions. The agenda roughly is 5 minutes of what the heck is reality computing, a few examples or analogies to help you sort of ground the concept, and then I want to spend 10 to 12 minutes really on some examples. So more specific things about what Autodesk is doing, where we're investing, and how we see things going. All right, so getting started, really reality computing, we view it as a new generation of computing, like mobile computing, like cloud computing, like any of these type of new generations or new platforms. It's the convergence of several technologies. For mobile computing, for example, you needed good batteries, you needed great low power processors, you needed a network, you needed all of these different things to make your smartphone happen. For reality computing, we see a revolution happening in the scanners out there. Scanners are getting much cheaper and soon to become radically more cheaper. I'll show you some of that. And we see a revolution happening in the computing. You can actually get a whole boatload of data up into the cloud and do useful things with it. And we also see a revolution happening out on really expressing that reality back into the world, whether that be 3D printing or something like an Oculus Rift where you can actually see it and experience it. So there's these, like any of these sort of shifts, we see several trends converging. Today it's really about opportunities for this computable world. Our mission as a group is to make the world computable, and I'll explain a little bit what that means going forward. First, an analogy. So Eric made fun of this tainted love. It's just the one that happened to be most accessible online, but this is how people used to share music. I'm not a musician. I do not know how to read this, but there are specialist people called musicians out there who know how to read this. You could hand them this piece of paper and they could then create music for you. It used to be that this was really a big industry. You'd have catalogs of sheet music. You'd have people who made their livings creating sheet music. They actually advertised in sheet music. It was that popular that you would share this around and you would get together with your family or friends and make music in the evenings and on the weekends. And you'd get something like this, right? There'd be a song or several songs, and you get a nice little bound book, and you'd be able to sort of make music. Looks a whole lot like a plan set, doesn't it? Or a mechanical, set of drawings for a mechanical piece of equipment. For the specialist, you can hand this to them, and they can make something. But then this happened, right? You started being able to record music, and you could share music in a recorded way, right? So now these are 8 tracks for people who haven't seen those. Those are even old for me. But you now can share music in a way that's much more accessible. Anyone can listen to music as long as they have the player. And then music turned into this. It turned into ones and zeros, right? Music became computable. You can now take this thing, sample it, you can take frequencies out, you can basically manipulate it in a computing environment And what happened? Lots of things happened. The iPod happened, right, which at first was a music player, but really was sort of a way of overturning the music industry. This middle one, rip, mix, burn, right? Remember, you used to have a CD, and you'd make mixed tapes, is what people used to do, and then they were able to take songs, rip them, mix them, and then burn them onto their own CDs and take them with them. And on the right, what else happened? The music industry cratered, right? This is a plot of revenue in the music industry in about 2001, peaking at $12 billion, so a pretty sizable industry. And just look at that, going off a cliff after digital music came. So the fact that music became computable had all of these implications and opportunities. It made Apple a first on its way apparently to being the first $1 trillion company, and it destroyed a $12 billion industry. So what happens, sort of taking a little closer, what happens when buildings become computable? So again, it just looks really similar. On the left is sort of a historic drawing of I think maybe a cathedral in Italy, but it looks a lot like that sheet music, right? So if you know what you're doing, you can probably build that, you can measure it, you can figure out how to get that thing done. Then we went to modeling, which is fantastic. Don't get me wrong, Autodesk is all about modeling, but this is still a representation of reality. This is still an abstraction. This is, to me, similar to having a piece of recorded music. I can see what it is now. I can kind of see if I'm going to have an office here, what my view would, or what it would look like. I can kind of get a good feel for it. But this is what reality looks like in a point cloud, and I hope the video is coming through. But much richer, much more compelling, and also accurate to several millimeters. So something that can be worked with in a computable way. You can measure it, you can cut it, you can snip it, you can color it, you can do all these things. And so finally, we're at the point where reality really is computable, and that's the whole concept of reality computing. All right, so the 3 pieces to reality computing, I'm just going to talk about them real quick. Capture, compute, create. You'll see this in some of our stuff. It's just shorthand for sort of the pipeline. So on the capture side, it's about getting out there and sensing the world, whether that be with a scanner, with a camera stuck to the bottom of a GoPro, whatever it is, but you're out there sensing the world, you're measuring it, you're lining it, and I have it in here sequence because I view DNA sequencing, that's a little out there, but DNA sequencing really is reality capture. You can put your DNA in something and it'll tell you the order of the A to C, T's and G's. Then you go into compute, you got to take all that information, you got to aggregate it, you got to analyze it, model it. Basically anything you would do in a compute environment is this middle section. So this is all of the digital manipulation. And then finally you create. There's really 4 types of create, right? You're going to publish something, publish a digital experience or a view or an AR. You're going to build something, you're going to augment something, or you're going to fabricate something. So what I want to do today is talk about those 3 real quick, and then I'm going to talk just one example each about the types of applications. There's 3 types of applications that I think are interesting. One, which many people are aware of on the call here, is reality enhancing CAD. So I can do my CAD stuff or my modeling stuff better with reality. Another one we call direct reality is you don't even touch CAD at all, you just use the data directly. And finally, the third one is reality is really changing CAD or really driving a next generation of CAD. So I'll give one example each here. But first on to capture. So we say this thing, data from things, that's capture, right? Things from data, that's basically being able to create a physical object or a physical building out of digital data, and then what happens in between. So we'll start with capture. So just a quick animation here. I think we're familiar with these terrestrial scanners, the ones that go on cars, LiDAR, but there's really a whole new generation of these things flowering, and I'll talk about them just real quickly, several of them here. So top right, you've got your aerial capture, but then right underneath it is what's happening is pretty interesting around drones. We think there's been about 500,000 drones sold in the last 3 years. A lot of people doing that to follow their cats around the yard or watch their kids surf or whatever it is, but certainly a new capture platform. Down on the bottom left is a personal genome sequencer, so you'll be able to take a cotton swab and put it in your mouth and swipe that, and someday you'll be able to get your genome sequence for about $1, and you'll be able to create personalized pharmaceuticals. And in between, you see some interesting things happening. Certainly the GoPro on that dog, everyone's got a smartphone. The smartphone not only has a great camera, but it's also geolocated. That middle one in the hand is a Velodyne scanner. It's basically what is in the car without the inertial stuff, but in something that fits in your hand. So you can do mobile scanning now with a handheld level of sort of compactness. So what does that look like? So this is, for folks who aren't familiar, again, if the video's coming through, this is what a terrestrial or mobile scan looks like today. Quite phenomenal. You get the color, you can stitch together giant sets of data. This is Market Street in San Francisco. There's an art project that's actually going to run on those wires you see. And so we scan the whole corridor, and in the back you can start seeing other parts of the city sort of showing through. So this ability to have city scale, photoreal, millimeter accurate data is here. It's quite revolutionary, I believe. All right, so next type of scanner we'll talk about is a GoPro mounted on the bottom of a DJI drone. This one, I believe it's a Phantom. There's several generations since then, but as many of you may know, we have something called a ReCap 360 photo, which takes overlapping photos and reconstructs them into a 3D point cloud. And so, again, leveraging this interest and really the energy around 500,000 of these things being sold, we have several customers who are using aerial capture in this way to generate their point clouds. So in this case, this is actually aerial capture plus some internal capture. That's why you have that internal cavity there that you can see on the top left. And so that's another, I think, sort of revolution happening in the capture space. But it doesn't have to be a drone. This is actually an iPhone out the window of a plane landing in Las Vegas at AU. And being able to take those photos just out the window, snap, 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 and getting this relatively good terrain model, whether it's engineering grade, I don't know, but really you can tell the mountains are, you can measure relative distances, slopes, that type of thing. It's pretty amazing. And then what does it look like when one of these come together? So this is the Velodyne handheld scanner shoved under a monster UAV. The sound on this is really terrifying because it sounds like 7 chainsaws taking off, but you get the idea. Soon enough, you'll be able to fly one of these UAVs around with a scanner and get LiDAR accuracy, LiDAR data, 1 square kilometer in 20 minutes. So the type of rapid response, the type of amount of data is really amazing what's changing these days. It's also a whole generation, and this is just a data sample, but a whole generation of mobile scanners. So rather than scanning something, or I should say mobile real-time scanners, rather than scanning something, sending the data into some sort of processing pipeline and getting it out hours or days later, this is really processing and stitching this all together in real time. In this case, a stairwell. And so folks like Google, Tango, this happens to be something on Carnegie Mellon, there's a company called Dot Product. There's dozens, literally dozens of companies that are doing this mobile capture now. Underwater. So you're starting to get some very, very compelling underwater data sets with sonar, which is quite amazing. And then my last slide on this is really, you start seeing some of these ads. The guy from, what's the show? The physics show. Everyone, I forget. Anyway, they're doing these ads now with this Intel RealSense. And so what does Intel do? Intel takes technology, it shoves it into small form factors, and it makes a gazillion of them. And then they get on this curve where every 18 months they either get twice or half as much as expensive or twice as powerful. And so they're doing that with 3D technology now. So this is a camera that on the front of your bezel on your PC will capture your gestures, but they also have a world-facing one that's going to be in the Dell tablet for Christmas, which is basically now. They'll let you capture the world. And so this is just some examples of the energy and sort of the investment going on in the capture space. Now, create things from data. So I'm going to do it from the left side from capture, and then I'm going to go into create, and I'll fill it out in the middle. So things from data. So really the 4 things here on the top left: 3D prints, CNC fabrication. Top middle, this being able to do models, layouts, being able, then the bottom, be able to do experiences, explorations, and then measurements, reports, and validation. So I'll show you that, but really this is the so what of capturing the data, is you want to actually create something. So first one here is something called Autodesk point layout. And so what you do is you define a number of points, number them on your Revit model. That gets transferred directly into BIM 360. That tablet then gets mounted on basically a prism for out in the field, and using a total station you can precisely locate your points. So this is basically taking digital data and translating out into the analog world in a very accurate way. Another one we're going to see later is printing. So on the left is a coral that we scanned, and then on the right is a print of that coral. So this is another sort of manifestation of create. And then this is an experience, or an example of an experience. So this is Smithsonian X3D. We worked with Smithsonian on this last year. being able to capture some iconic objects within the Smithsonian collection and turn them into online educational experiences. So this is zero client. This is something that you can go to today and check these things out, but really being able to take these physical objects, capture the full reality and the full complexity and the full beauty of them, and then be able to share them in some sort of an experience. So this is another type of create in terms of creating experiences, creating educational materials, creating these sort of online assets. This is a woolly mammoth. You can measure it. You can print it. All of these you actually can basically right-click print, which is pretty interesting. And so this is just an example of create. Another one is something Eric's quite familiar with, is this idea of going to documents and reports, right? So you've got your laser scan of a highway. What you really care about is, are my trucks going to fit under it, and I owe a clearance report to the state on Tuesday. How am I going to do that? Well, you're going to basically automate the process of taking these data, this point cloud data, turning it into a report, and then delivering that. All right, in the middle is really where the juice is in this whole thing. So we call that compute, all right? That's the reality computing piece. So you've got laser scans on the left. We talked about sonar underwater. We talked about other sensors, temperature, that type of stuff, sequences, photos, CT scans, whatever it is. On the right, we know we want to create a layout. We want to do some sort of fabrication. We want to create an experiment, or we want to create an experience, or we want to create a report. How in the world do you do that? Well, that's compute. And so you need an aggregation engine, and you need to be able to work with this data in a computable way. So this is a large mesh data set, and the reason I'm showing this is just to show you sort of some of the fidelity that you can get in our products today. This is product Memento, so I think there's 200 million triangles in this, and this is real time working with it. The important part is this, though. Underneath that data is a hierarchical structure. So if I want to search it, if I want to measure it, if I want to diff it, I can do all of that because it's a computable structure, right? It's just like being able to do something in an Excel data sheet or spreadsheet, really, but it happens to be 3D data, but it is indexed and it is organized, so you can do that. This is a plant data set, and what we want to show here is, again, just sort of some special toggles that we have. You can see that behind the scenes we are calculating all these logical regions and areas. And that's great because I think that sort of is a foundational thing, but what can you do with it? The next one here will show you. So this is some sort of a vessel there in the middle, that EX330. If you want to measure how far it is off the ground, you can go and you can guess where the bottom of it is, and you can guess where the normal sort of perpendicular is, or you can just select it and we'll tell you, hey, it's a cylinder, because we already sorted that out, and we know which way is up because you've told us, and so we're going to tell you exactly how far it is from the ground. And even if you move that vector around, or that little arrow around, we're going to keep telling you the XYZs accurately. So this is the type of thing that we mean by computable. Is it's not just reference data XYZ, but there's actually intelligence behind it to let you do things like ask you questions and search it. Eventually where we're heading, this is not Autodesk, I should say, but eventually we're heading to something like this. You've got a scan up top left, you've got a CAD model up top right, and bottom right is the difference, right? So I'm supposed to build the thing on the top right. The guys say they're done. I scanned it, and by the way, they missed half of the vertical sort of guardrail members, and a whole bunch of stuff inside is unclear, but being able to really diff your as required or as designed with your as built is where this is going once the data is intelligent. Same thing here, so being able to have a CAD file diffed with a captured mesh. In this case, this is some sort of a bracket for hanging a camera off of a kite, actually, that one of our guys is building. But you get the idea, being able to understand, did I build what I was supposed to build? Did the printer actually print what it's supposed to print? All right, so applications. So reality enhancing CAD, direct reality and reality driving CAD, I mentioned this. Just one video each. So reality enhancing CAD, I think this is going to be pretty familiar to many people here. This is a point cloud, and this is your AutoCAD, and you're able to snap to walls. You're able to quickly snap this wall in place and visualize it. This is also AutoCAD, so this is more of a full building set. Be able to geolocate it, orient it, and work with it directly in your CAD application. Be able to then overlay these templates of windows and very, very quickly get floor plans and sections. The Golden Gate Bridge in San Francisco is sort of an infrastructure scale project, being able to do your quick design conceptual. This is actually doing animations on the point cloud directly, so this is 3ds Max, so being able to work that way. This is the same data set we saw earlier, capturing with the drones, taking into Revit and being able to very quickly take that and create your deliverables out of that, your sections. This was actually design that was done on that data set and then creating sections from that. So that's a very, very, very quick tour, but you get the idea, really reality making CAD better. Let me talk to you about direct reality. So this is the same data set we saw earlier of the bridges, but this is actually then processed for only the things you care about. I care about the center lines of the road. I care about the roadside furniture, they call it, the assets, the signs, that type of thing. I care about the bridges, and then creating a asset inventory directly off of those point clouds. So again, there was no CAD involved here. You had to clean up the point cloud, granted, do a little intelligence on it to find the characteristics you care about, but there was no CAD. You directly found your assets. And then finally, the printing one. So there's that same coral we saw earlier, and we're going to go ahead and take several photos, in this case about 200 photos. We're going to load it into Project Memento. It kicks it up to the cloud for 3D processing, and we're going to get back that 3D model, and a very, very accurate one, I should say, because it's a nice textured object that really gives great results. So I'll let this go. And what you'll see is you're able to view it here. Incredible detail, no color, but incredible geometrical detail. And then say, you know what, I think I want to go ahead and print that. And when I want to go ahead and print it, again, I didn't use, you could call this CAD, I guess, but I'm not doing any models. I'm not doing lines, arcs, circles. I'm not doing objects, CAD objects. I'm not doing operations. I'm really just cleaning up this data, and I'm kicking it out to the printer. So this is, again, this idea of direct reality. We think there's going to be more and more and more of these, especially in areas like demolition planning, where really all your modeling is doing is giving you idea of what you're going to destroy. So why wouldn't you just capture it? We see a lot of this in medical, where you want to fit something to a foot or a prosthetic or something like that. So this idea of direct reality we see really taking off. All right, and then finally, this is just an underwater coral, well, underwater photos of a coral. And like before, being able to do a diff analysis of this. So today, if you want to know how well a coral is growing, you go underwater with basically a grease tablet with a grease pen and a tape measure, and you stumble around and bump things and hurt things and all that. Why wouldn't you model it and then come back several years or months later and model it and then you can tell what's changed. So this is, again, a direct reality application. No CAD, no modeling. All right, final one, reality driving CAD. So one of the things that's interesting is, I'll just jump right into it. We have a company Autodesk bought recently called Within Labs. What they did is they really are creating the next generation design software that lets you create internal structures of things. So we've known that internal structures are important really for thousands of years. Top right is a human bone, and you can see some of the striations there. It really grows based on where the stress and loads are. Bottom middle is a bird bone. They call them pneumatic bones because they're completely hollow. So we've known since Leonardo da Vinci that the right way to make something light and strong is to make it hollow. But we just haven't been able to make things hollow in a predictable way. That's really changing, especially on the create side. So within labs lets you do things like this. That top is a cranial implant. This bottom is a lightweighted bearing sort of support. And then this here in the middle we'll see more of is an implant for a hip replacement. And so real quick, this is a computed, by the way, geometry that's grown and printed in metal. And that is not a random shape in any way. That is the right shape and porosity for the body to recognize it as quote unquote weak bone. And what that means is if you put that in the body, it's going to say, I got some weak bone here. I need to get in there and strengthen it up so that your bone will grow into that structure. So that's a very precisely designed and computed structure that's been able to grow in this form. That was just not possible before 3D printing. And so how do you do that? How do you go from knowing how to, what you want to do, having the technology on the right to really deliver it, but how do you actually think about it? Well, Within Labs gives you all of these different internal cell structures and matrix structures. So here's one, here's another, here's another. So really they're giving you the engineering capability to go and design inside things, like hence the Within Labs. This is that's a quick video which shows basic 3D lattice. And what you can do is you can actually increase or decrease the thickness of each of these members based on the strains that are seen in the product. And so really, again, you're engineering the inside. So this was having reality really drive the next generation of CAD. And I'll just stop that because it's, I know we're short on time. This is what the product looks like in for an engineering application. This is sort of a cantilever beam. You give it a series of loads, and you give it its connection points, what it needs to do, and just go ahead and doing some of that, and it will just iterate through. It'll just sort of chunk away and give you iterations on what's the best cell and lattice structure for that. And so I'll actually speed that up a little bit, and so we can see what that looks like. And so you start seeing the finite element analysis. The FEA happens right on in real time on each member. That's why it's colored red and green. And then they grow and shrink and sort of optimize over time. You see this curve on the top right is sort of top left, sort of this optimization over time kind of coming down. So anyway, that's a very quick tour. So that's sort of reality computing at Autodesk, and I think my closing comment here really is I believe that reality computing is Autodesk. If you really think about what Autodesk has done for 30 years, it's about taking the computer and letting it kind of helping the designer, the engineer, create things in the physical world. It's just we've had to shove it into and dumb it down into CAD geometry before we could do something useful with it and get it back out. Well, that's no longer the case. Now you can get the full geometry, the full complexity into the computer, do cool stuff, and express it out through these new technologies like 3D printing that just weren't possible before. That's a rapid run through of reality computing. I'd love, if we have time, to take any questions.
All right, thanks, Robert. So, as we said, if you do have any questions, please type it into your question widget there in the go to webinar panel. And yes, some people have asked. We are indeed recording this session. We'll be posting this on YouTube shortly. Probably not today, but before too long. So you can certainly go back and watch that at any time. All right, we have a question about somebody asking if the full AU version of this talk is also available somewhere.
Excellent question. It is not. I think I can make the slides available, but they did not. We were meant to be recorded, but they had a glitch, and so it was not recorded now. If you want to search on it, though, it's the Reality Computing Keynote. It's called, and it's the data from things from data, and what happens in between.
All right. Okay, so here's a good one. So this one, relevant to us as a software team, what pieces of software, can someone look into to start to get an idea of, this whole reality computing thing? What's a good starting point from like a software side?
Great question. So reality computing really spans the whole gamut. It goes from capturing and ReCap all the way through whatever sort of product makes sense for you. Is it Inventor? Is it Revit? Is it AutoCAD? But I would say the place to start is with Memento, Project Memento, MEMENTO. It's on Labs today. You can just search Project Memento. You'll find it. It's a free product. What it lets you do is use your camera to capture images, overlapping images, and there's videos in there about how to do it correctly, overlapping images of an object or a building even, and then be able to compute that into a 3D model, and then be able to take that and either print it, view it, export it into AutoCAD, export it into Revit. So that's one place to start. If you have access to a laser scanner, which many people don't, they're a little expensive still, but if you have one in your company or if you have access to one, certainly go the ReCap route. So ReCap is really your processing pipeline for laser scans. So taking scans of your office, for example, being able to work that within Revit, AutoCAD is the way to go. So I think the easiest on-ramp is Memento. If you've got a laser scanner, go ahead and get ReCap. By the way, ReCap is free as well. So.
All right, great. Anybody else have anything? Let's see. And just, important to mention, we are going to be running a conference in February out in San Francisco at Fort Mason. That is the Real Conference, Real 2015. You can see the website at real2015.com for more information on that. So that's in addition to realitycomputing.com, that's another resource if you guys are really interested in this sort of thing. All right, we have time for maybe one more question. How large can an item be 3D printed today, and who does it?
Yeah, I'm not even going to touch that because I'm not a 3D printing expert. It certainly obviously depends on which machine. If you don't have a machine, I wouldn't suggest buying one. I would suggest going to something like Shapeways, something like Materialize. These are companies that have basically fleets of 3D printers in warehouses, and you send them your design and they will print it for you for a small fee. So I would look at those places first. And then just quick on Real 2015, yeah, we do plan on having quite a bit of hands-on demos there. So in San Francisco, Fort Mason, end of February, we'll have a talk. We'll have several talks about the implications of reality computing across several industries: art, education, AEC, manufacturing, heritage, first responders for natural disasters, all these different areas. But there is also going to be hands-on opportunity to get your hands on some of these scanners and technology.
All right, great. So thank you, Robert. Thank you, everybody, for joining us. Just to kind of wrap things up, like we said, we did record this session. We will be posting this on our YouTube channel in the coming days. Again, if you have any comments, questions, feedback, anything at all, feel free to reach out to us. You can check out the Reality Computing blog at realitycomputing.com. You can send us an email, realitycomputing@autodesk.com. Otherwise, we really appreciate the time. Thank you to Robert. Thank you to all of you, and we hope everybody has a happy holidays, and we'll see you again in January, hopefully. So, thank you.